50. Okay, today guys, you're doing 3-3 as you already saw with your homework. Today is the properties of logarithm. I'll get it again later. I'll show you. 3-3 is the property of logarithm. So we already taught you something about last time because I taught you guys how to do change the base, right? And I thought that was on last time's homework. It's on today's homework. Okay, so remember, there was times that I couldn't write log base 2 of 5. I cannot tell what that is, okay, especially back when I did math because I did not have the cool calculator like you guys did for subscript 2, right? Make sense? Everybody with me? So, what did we do if you didn't have the cool calculator? Go ahead. If you have to do it. That's right, you don't do that. Oh, wait. Go. Log of 5 over. Now this is called the common base change of base. They call this the common log logarithm because it's base 10. That's the common log. Okay, like you said. Or what else could you have done? ln of 5 over ln of 2. And which one do I usually do? Because it's 2 less letters. And somebody's like, Mr. Roberts, how was that 2 less letters? And I'm like, then I had to show it. She's like, that's only 1. And like top and bottom. And you're in honors class. Wait, was that last time? I'm not even. Well, Mom, you should have class with Mr. Roberts. Okay. Now, also, I could do it. What if I said change the base to base 7? What would you do? Log base 7 of 5 over log base 7 of z 7 of 2. Because as long as they're the same base, I can still change the base. Because these are the same base, aren't they? And these are. You would never want to on that case. If I was using my calculator, I'll show you one that you might want to. Okay. Let's say I say, okay, find this without using your calculator. Without using your machine. Yeah. A1, she's in A2. So put that into the A2 basket. So this one, I could do this fashion and go 16 to some power is 1/4, right? Do you ever agree with that? Then what? Oh, this is 4 squared to the question mark. I'm going to put x instead of question mark. Is 4 to the negative 1. So that's 4 to the 2x equals 4 to the negative 1. And then I could solve and say 2x is negative 1, x is negative half. I could do that. Look how many steps that is. Correct? Good. That's horrible, huh? Watch this. If I change this to base 4, how would I do this if it was base 4? Log base 4 of 1/4. Log base 4 of 16. 4 to what power is 1/4? 4 to what power is 16? That's an example of why you might want to change it to another base besides 10. I would not put that in my calculator. You could, but yours would suck on yours, yeah. But you get what I'm saying. But there is purposes of why I might still want to change the base. Like here, if I told you to do that, wasn't this a lot quicker? I mean, I could still do it, but this was a lot simpler, wasn't it? Because I can get 16 to base 4 and 1/2. I mean 1/4. I could do them to base 2 if I wanted to. If I put this as 2 and this is 2, 2 to what power is 1/4? Negative 2. 2 to what power is 16? 4. Negative 2 over 4. Just something you can get common bases. Now, is that very often? Sometimes, right? Not always. You'd still do the first way? Okay. That's completely fine, but you see how it could work though? All right, any questions? We're rolling, we're cruising. I'm gonna be done in 15 minutes. Now, you guys remember, do a timer right now, put it on. I said 15 minutes, so you tell me when I need to start. Like skiing almost. Ready, start. Okay, so remember, yesterday we talked about an exponential and a logarithm are inverses, right? So a lot of the things that we do with exponentials are in logarithms as well. So I'm going to do a few properties in exponentials that transfer kind of into logarithms. Can somebody tell me what is x to the m times x to the n? Actually x plus m plus n, right? If I had x squared times x to the 7th, that's x to the 9th, right? Because I'd add those together. Would that be correct? Okay, so let's about this one. We've already known these rules. I'm just bringing them back up. We would subtract them, correct? What happens when I have a power raised to a power? We multiply. Okay. Now those are going to come in very much with a logarithm. You guys ready? Can I switch on? Okay, here we go. What is log base A of B times C? Look, I see multiplication. When I do multiplication, what did I do to the exponent? Add them. So guess what I can do here? I add them. Because really, aren't these the powers, or these are the results, right? But just suck it in and say, I believe. Yes. So hence times when I do addition. So here, what am I going to do? See division, right? Uh-huh. With me? When we saw division, did we subtract the exponents? Division, subtraction. See how it's kind of working? B raised to the C. What do we do when we have power to a power? Multiply. So I have C log of A of B. Notice he came out and multiplied. Nope, not that way. So he's a power, so he comes out to be multiplication. This is C times log base A. I'm going to show you how it works right now because it's going to make sense. Okay? Let's start with this example. What's a way, just using that formula that I just showed you, what would that be? Right? Let me show you a better clarification. Some of you guys maybe didn't agree with this one so much. You're like, right? What's another way to write x cubed? X times x times x. Would you guys agree with that? So when I see multiplication, what do? Add them. Don't eve them. I'm just... Thanks a lot, jerk. Appreciate it. How many of those do I have? Okay, let me show you something else. We already decided that that was log of base 2 of B minus log base 2 of C, correct? What's another way I could write this? B times, okay, 1 over C is very correct. What's another way to write 1 over C? Right? What do we do when we see multiplication? Add them. But what do we do with that exponent? We bring it out front and multiply it. What's positive 1 times negative 1? Another reason why we subtract. It shows you using both of those. All these powers still work, huh? Pretty nifty? Okay, so those 3 rules are our rules that we're using today. When I see multiplication within logarithms, what does that mean? We're adding. When I see division in logarithms, that means when I see a power being something raised to something, that is bring that out and multiply. So our goal today is to expand. So if I have this, I would like us to expand that. What do we see first? I see timesing and a division. Whenever I see a division, I do that first. Okay? So I say, okay, this is log of x squared y squared minus log of z. Because the division makes us subtraction, right? Does that make sense to everyone? But what does this say? Those are multiplying, so what do I do to these guys? I will add them. So I will have log of x squared plus log of y squared minus log of z. Am I done yet? What's the last thing I'm going to do? Bring the powers out to the front and multiply, right? Does that make sense? So this will be 2 log of x plus 2 log of y minus log of. How many minutes do I have left? 7 minutes. Okay. I have to rush a little bit more. That's pretty good. Is that hard? Okay. I would like you guys to try for yourself. Try for yourself. Here we go. First thing I see is division. Oops. Not yet plus. Okay. Now, how many forgot to put your parentheses and just had 2 log of x minus 2 log of y plus log of z? How many of you guys had plus log of z still? 1, 2. How many of you guys didn't have this parenthesis here but had the same thing? With that, so it'd be 2 log of x minus 2 log. But if you don't have the parentheses, it's not the same thing. That and this and this are 2 different things, are they not? How many of you guys had this? Except with the 2 out front. That's the half of the people I thought would get that. Because the parentheses does matter. Because what are you going to do with that negative? Distribute it. Nope, so I'm going to go 2 log of x minus 2 log of y minus log of z. No, not anymore, because I distributed that negative through. How many of you guys forgot to put the negative in front of the z? That's what I'm trying to do. Because you got to distribute them through, right? How many of you guys forgot the parentheses and you're just like, oh, these 2 are downstairs are timesing, so they're plus, right? That's what you're thinking. But you got to understand, just like that example I brought up, another way to write this is that this is y squared coming up, so that's y to the negative 2. So that'd be a negative power, right? Z is also downstairs, so what's his power? Z to the -1, so he would bring down a -1 power. Does that make sense? Another key rule, if anything's downstairs, they will always have a negative out front of them. Okay? This is the way to write. That is the way to write. That is the, I'm showing you there's a common mistake of keeping the plus. But if I pull out that negative, then there's still a plus in between. That makes sense? By the way, this is another way to, sometimes we go condensing, that's what we're going to do in just a minute, where we're going to go backwards from this stuff to this. My general rule is if it's positive, it goes on top. If it's negative, it goes on bottom. And it makes sense because watch, I have x squared divided by y squared, then again divided by z squared. What is this over that? Or z, just notice I times by the reciprocal. See how he still stays on that? Okay. All right. Are we okay on expanding? You feel good? Should we do how much time? Okay, I gotta be quick because I got it. I'm almost done. We'll hurry and do this one. You guys hurry and tell me what that would be. That's a cool eyeball. The log of x minus 3 log of y.
Are we like unexpanding?
So now we're condensing. So this would be 1 logarithm. What's on top? X, no, not log x, just x. Because it's log of x. Y cubed would be down below, right? With me? All right. Okay, that was pretty simple, right? Now let's do a hard one. All right, we'll be good. Yep. Today's just expanding and condensing and changing. Okay, what did you guys do first? We're going to condense into 1 logarithm. So it's all going to be ln, but I would want to first distribute this 1/3. Make sense? Nope, don't hit zeros. Ooh, can I change that to a z instead? Sorry, guys. Yeah. Now what do we do? The powers go where? I mean, the numbers out front go powers. What's another way? Notice, guys, all of these are ln. How can I write minus 2 as an ln? Minus 2 as an ln. Well, let me show you. This is the same thing as minus ln of e squared. Why? What's our base here? E. So if I do e squared, remember if our bases are the same, don't they get rid of each other and then that's just 2? Yes. No. Does everybody understand how I did that? ln of e squared is 2 because what is e to what power is e squared? 2. Or another way to do it is you know it has to be ln of something, but we know it equals 2, right? Does that make sense? What's our base, even though it's not there? E, then change it to we're in logarithm. Dang it! We're very close. We change it from a logarithm to an exponential. How do I change this to an exponential? E squared is that question mark, so hence why I'm putting it right there. Really quick, I'm going to come back to this. What if I had it, all this other stuff was base 4, right? And I said plus 3. What would be that plus 3 the same thing? It would be log base 4 of 4 to the 3rd, which is 60. Does that make sense? You're writing just a little equation, or as you just did, Daniel, that's actually pretty good. Just keep it as that power, 4, because that's how those three agree each other, right? And what is 4 to the 3rd? You're here today. You're here today. You're in my room today. Well, no, meaning you also have the lab.
Oh, yeah.
You forgot about that, didn't you?
No, I didn't.
Okay, so notice, guys, anything with a positive, where do they go? Top. Anything with the negatives, where do they go? Bottom. So, ln x to the 1/3 y over z to the 6th e squared. By the way, I'm going to test next Thursday. This is going to be 2 days ahead of you because you've done that packet.
Right.
I decided that when I'm going to be gone,
Yeah.
I might as well just give them the review.
Oh, good idea.
Because I'll be right on the
Right.
review.
Yeah, that's perfect.
And then I can
But-
teach those
and then
other
you-
days
After you get back?
after.
Oh.
Because you're not putting them on the test, are you?
I might have one of my best, but that's okay, you don't need to.
There it is. That's it. That's our lesson. I wasn't too far off. Too bad, right? I've been a minute. Anyway, that's all you gotta do. Condense it back to 1. Okay? Once again, if you did not know, or is that enough, or can I? Here's your homework again. You guys have 20 minutes, 25 minutes? Go ahead.